Hello, my name is Darren Thomas and I'm the Director of Educational Research Techniques. In this video, we're going to learn how to calculate z-scores, which is a critical piece of information that is frequently used throughout different types of analyses inside the world of statistics. So why don't we go ahead and begin. So with the z-score, what you're doing here is that, and this is very, very simple, the z-score is something you use with the standard normal distribution. As you guys are probably familiar with, again, we don't have time to review everything in statistics, but as you're probably familiar with, at least superficially, is that it is common to see that a normal distribution is something like this when you have your data points. So if you were to plot your data points on a histogram, if you will, there would be something looking like this beautiful little bell shape that we have. We call this a normal distribution. It's called a theoretical normal distribution because this is how it should be most of the time. Now, what happens here normally is that when you have this distribution like so, is that frequently, right here in the middle, you have your mean, so your x bar if it's your sample. And then, of course, you have your standard deviation. Your standard deviation is the average distance any given data point is from the mean, which is normally in the middle. And of course, with a theoretical normal distribution, of course, is in the middle. Now, here's the thing. There's nothing wrong with the normal distribution except that, different samples will have different means. And what happens is that it becomes difficult to compare different distributions when you use the mean that they come with and also when you have the different standard deviations. So to alleviate this problem, statisticians created something called a standard normal distribution. And it looks just like any other normal distribution, except there's one more thing that's a little bit more unique to it, in that the mean, sample mean, is always set to 0, and the standard deviation, if you will, is set to 1. And so what happens is that I can take any distribution that I have that is normal, if you will, and I can fit it to a standard normal through using the z-score expression or the z-score equation. So let's just say, I have, the average height I have the height of men, men's height, if you will. And I have their weight also. Now, the problem with this is that height is going to be measured in centimeters or meters or inches, and weight is going to be measured in pounds or kilograms. Since they're in different units, it's very difficult to compare them. But when you standardize them through using the z-score, you're able to compare men's height and men's weight or whatever for other things such as correlations and other things of that nature. Now, what we're going to do now is that we're going to look at how exactly to calculate the z-score. And there's one more thing I need to mention before we go any further. Another benefit of the standard normal distribution and calculating the z-score, if you will, is that the z-score allows you to measure exactly how many standard deviations any given data point is from the mean. And we're going to take a look at that in the next little slide here. So how do we calculate the standard normal distribution? Well, it's very, very simple. You have your z here equals x minus x bar, all this divided by the standard deviation. This is the actual, if you will, equation for doing this. Now, let's go ahead and do this for one little quick example here. Let's just say, here's my data. So I have x, is going to be, 3, let's see here, 3, 5, and let's see here, 7. All right, so this is my data right here. I have 3 data points, 3, 5, and 7. So my mean for this, and let's just say, of course, I can already tell you right now that the standard deviation for this is going to be 2. And the mean is going to be 5, because 7 plus 5 is 12. 12 plus 3 is 15. 15 divided by 3 is 5. So here's all my information. Now, I can calculate the the z-score for all of my individual data points here. So let's just do it right now. I'll do it for 3. We're going to do it right here for 3. Let me go ahead and make this clear for you. We're going to do it right here for 3. That's what we're going to do. So how do I do that? It's very, very simple. See if you can follow my thoughts here. I take 3, that's my x value, minus my mean, which of course is 5, and I divide all that by 2. All right, so what do we have here? 3 minus 5. 3 minus 5 is going to be negative 2 divided by 2, and that gives us a z-score of negative 1. So what does that mean? This means that the value of 3 is 1 standard deviation below the mean, which is 5, which makes complete sense because the standard deviation is 2, and how far is 3 under 5? How far below? And we know that, 3 minus 5 is negative 2. So let me make this clear. We know that the number 3 is 2 units below 5. We know that, and our standard deviation is 2. This is why our z-score is negative 1, because 3 is below 5. And it's below 5, 2 points, and 2 points is our standard deviation, is 1 standard deviation. And that's why we got the negative 1. So this is what's happening. Instead of having some other calculation here, you have this pure calculation of negative 1, because that is when you standardize it, how far it is. And now, if we did this for positive 7, I think you already know what the answer is going to be. Let's just do it real quick for positive 7. So this time we have 7 minus 5, all divided by 2. I don't think I have to do all the work for you this time. I think this time you know it's 1. Why is it 1? Because 7 is 2 units above 5. And every time we have 2 units, it is going to be 1 standard deviation in the standard normal distribution. I know this is kind of confusing, but that's how it works out. And so this is the value of this. And so now, no matter how I measure my variables, no matter what kind of units, when I standardize them, everything is in one type of unit. It is a standardized or a standard unit that is very commonly used in statistics. So in this video today, we took a look at how to calculate the z-score. The z-score is very commonly used as a foundational statistical tool for much more advanced concepts inside statistics. And so what happens is that you take your distribution, of course it should be normal, and you are able to measure, or you're able to compare things that are measured in different units, and also to figure out what is the distance of any particular, how many standard deviations any particular value is, how that distance is in terms of standard deviations. And so it's a very, very powerful practical tool that makes it very easy to do much more complex analysis in statistics. So my name is Darren Thomas. I'm the Director of Educational Research Techniques. Take care.